The weak law of large numbers in IID case. You might be knowing about the IID case. The IID case is where the random variables are independent and identically distributed. That is what IID means. So here we are considering a sequence of random variables x1, x2, etc., xn, which are independent random variables which has same distribution with mean mu and variance sigma square. In the previous video of weak law of large numbers, we have considered the distribution where the random variables, where each random variable had a particular mean that need not be equal. But here we are considering the case where x1, x2, etc., xn, all of them has the same mean and variance sigma square. So, if x1, x2, etc., xn is a sequence of independent random variables with the same distribution with mean mu and variance sigma square, then for any epsilon greater than 0, probability of mod x1 plus x2 plus etc. plus xn divided by n minus mu greater than or equal to epsilon tends to 0 as n tends to infinity. So we are moving on to the proof. So for the proof, what we are going to do is we are going to take the notations that we have used in the previous video or in the previous weak law of large numbers for the general case. So let Sn be is equal to x1 plus x2 plus etc. xn and Mn be equal to expectation of Sn, which is equal to expectation of x1 plus etc. plus xn. That is the sum of random variables, the expectation of the sum of random variables. And here we know each random variable xn has the mean mu. So this is equal to mu plus etc. plus mu n times. That is equal to n mu. Now what we are going to do is, since xi's are independent, Bn is equal to variance of x1 plus etc. plus xn. And we can write it as summation I equal to 1 to n variance of xi, and which is equal to summation I equal to 1 to n sigma square. That is n sigma square, and that is less than infinity. That is, the variance is a finite value. Now, Bn by n square is equal to n sigma square divided by n square, which is equal to sigma square divided by n. So, limit n tends to infinity, Bn by n square is equal to limit n tends to infinity, sigma square divided by n. And since n is in the denominator and n is tending to infinity, we can see that this value, the limiting value Bn by n square, tends to 0. So, the conditions of weak law of large numbers, the general weak law of large numbers holds. That is, limit n tends to infinity, probability of mod x1 plus x2 plus etc. xn divided by n minus its mean is n mu divided by n greater than or equal to epsilon tends to 0 as n tends to infinity. So here it is x1 plus x2 plus etc. plus xn divided by n minus mu is greater than or equal to epsilon tends to 0 as n tends to infinity. So this is since this is a limit, we can write it as equal to 0. So this as n tends to infinity is also not required. Or we can write it as probability of mod x1 plus x2 plus etc. xn divided by n minus mu greater than or equal to epsilon tends to 0 as n tends to infinity. So this is the two type of notations that we use for the weak law of large numbers, or like in limiting cases where limit n tends to infinity, the quantity is equal to the value of limit, or the probability of this tends to that value as n tends to infinity. This is the two forms of writing it. So in coming to the weak law of large numbers in IID case, we can see that the probability of mod x1 plus x2 plus etc. xn by n minus mu greater than or equal to epsilon tends to 0 as n tends to infinity. In the other case, in the general case, we had mn by n, sn by n, and we had a condition that only that if bn by n square was less than 0, only in that case that value, that probability value was tending to 0. But here since the variance and the mean are both identical, it is comparatively easier to consider the weak law of large numbers.